So intent-driven RAN automation by Dr. Deepak Kataria. He's a principal solution consultant for Ericsson. And I had the pleasure of working with Deepak. He's also an IEEE volunteer leader, Princeton Central Justice Section past chair, also ComSoc vice chair. He has about 25 years of experience in different technical leadership at ENT Labs, Lucent, Fujitsu, and Agile. Then he co-founded his company, IP Junction, 2009. So he's an entrepreneur, IEEE leader, and he's also co-chair for IEEE Future Network Initiatives, AIML Working Group. He has a BS Engineering and Master's PhD from Rutgers University. He also completed Harvard's Emerging Leaders Professional Program. With that, Deepak, would you like to take it over? You have got 20 minutes. You're on line, right? Deepak?
Yes, I am. Yes, thank you very much. Am I audible?
Yes, you are audible. Please share your slides.
Okay, let me know if my slides are visible. I'm sharing.
Yeah, it's coming up. Yes, you can just put it on view mode, and you have 20 minutes. Okay, thanks, Deepak.
Okay. Thank you, Ashutosh, for the invitation and the kind introduction. I'm going to talk about intent-driven RAN automation, and I'm basically representing the AIML working group, which is part of the IEEE Future Networks Initiative, and I co-chair that working group. The outline is I'm going to tell you a little bit about that working group in the spirit of what we have heard about working with the open groups that we have, open source projects we have. Similarly, we have the IEEE FNI AIML working group as well. And I'm going to talk about the automation imperative that we have in general and what opportunities we have with automation in 5G networks. Then I'm going to focus on the radio access network automation, which is the focus of this presentation. And I'm going to motivate leveraging intent for RAN automation. And I'm going to give you some examples of how we have done POCs with intent-based automation for fixed wireless access and enhanced mobile broadband. These are two slices we have in 5G. And then I also talk about how we can take it further with automated radio resource partitioning, which is a capability we have in 5G networks, the ability to partition the radio resources among slices. Then we'll walk away with key takeaways. So let me start quickly with the FNI group that we have. So we have the International Networks Map Generations group that we have. And this is something that was founded by Ashutosh and his team. And within this forum, there are many groups. We have the access, the networks, system and standards that you see on the left. Within enablers and users is where the AIML group basically sits. So, and what we do is, interest areas that we look at here, we look at how do we use AIML for end-to-end orchestration and automation? How do we bring to bear zero-touch network and service management? How do we leverage intent? So the topic that you see talk today is basically intent-based RAN automation, which is derived from this interest that we have in this group. And we are right now looking at, so we have actually published, or in the process of publishing or releasing, the release 3 paper that we have. So every year we have a release that we publish. We had release 2 in 2022. Now we are up to 2023. We'll have, and they have topics that cover pretty much looking at AIML as a horizontal technology across the entire physical stack, across the entire network stack, if you will, right, from physical to the application layer. And we look at many things, as a horizontal technology, how it can be used by different verticals. So as part of that, we also cross-work with other FNI working groups. And we look at all hardcore issues that we have to make the adoption of AIML successful in these different verticals, addressing issues like interpretability, explainability, trust, things like that. Now, if you want to read about it, it's a very easy way. If you're an IEEE member, you just have to sign up for this. It's a very small fee to become a member of the Future Networks group, and that gives you access to all our white papers and chapters. If you are an IEEE member already, and you have a society membership, this access is available for free as well. So let me talk about the intent-driven RAN automation. So I think the automation imperative, I think is well known, because with 5G evolution, as we have more services coming online, the data growth happening, we have more devices because of more services, security happens to be an issue, customer experience. So when you have an operator who has to support these evolution of the services, devices, and experiences, there are some pain points, because the network has to basically deal with this complexity. They have to put in place the agility, which they don't have. But the automation is not as much as we would like. And they also, on the other hand, CSPs also want to have new revenue streams that they want to go, so they can have, better business outcomes, right, from the investment they're making in 5G. And if service is not good, they also have to protect their business, reduce churn, and low NPS is also an issue. So the business impact is obviously there. If you improve automation, if you have automation, it improves your workforce productivity, your net promoter score goes up. You have less churn as a result. You also have opportunities, if you have automation, to target new service revenues and reduce your OpEx, right? So all of those things basically are calling towards requiring automation. What are some of the opportunities, right? So once you have these opportunities if you are not able to keep up with this increased operational complexity by putting in data-driven operations or automations, that are boosted by AI to improve experiences and services that we talked about. If you're not able to do that, I think that you'll have a big gap between what customers expect and what you have to offer, as a network. So clearly, we have to move away from incident-driven operations to more like intent-driven operations, more. So I think there are the good news is that we have some key technology enablers to help us. We have AI, we have advances in automation, we have the agility of cloud. We also have, ML ops, machine learning ops, DevOps, data management. So there's a lot of advances we have in those things, which we can actually leverage these to give us a more like a data-driven operations, which is also intent-driven. Now that there are opportunities, right? We had the imperative automation. There's an opportunity associated with it. Let's focus on RAN automation. So 5G RAN is complex, as we heard. There are many band combinations we require. There is tuning required. There is more than just enhanced broadband service. You have fixed wireless. You have time-critical communication services, which have their own requirements, from the network. Now you're putting things to make it cloud native, to make it more agile. You also have to, deal with the instantiation and scaling of those services that are cloud native. If you want to do something that is fixed function or that is manually operational, try to do it manually, that becomes very challenging. So RAN automation, therefore, is essential to operate this network at this level of complexity. And with disaggregation, the challenge even goes up, right? So instead of managing one box now, the same box has split up across multiple boxes with open interfaces, and you have to basically manage, you have to deploy, configure, manage those deployments. So therefore, the rules that we have in the past, do not apply anymore, and we have to focus on RAN automation. So what we have, if you see on the left, right? If you have in the left the old ways of working, typically we have the CSPs. If you work with CSPs, they talk about golden parameters. They have these CIQs that they give you. That is okay. Let us configure this, and this will give us this target KPI, and you basically configure them. But that is actually suboptimal in the dynamic environment that the RAN operates with these new services and the new expectations that we have, from end devices, right? And even if you do it for one parameter, for one KPI, there is a dependency between other parameters, that parameter affecting other KPIs as well. So what we want to do is, instead of focusing on trying to configure each RAN function with their own golden parameters, is that let us actually not go deep into that, but actually create some abstraction So create an abstraction where the CSP basically focuses on the experience of basically providing, their requirements, quote unquote, as what they need or what is required, and separate the aspect of how that is delivered. So basically what we're saying is just offload the, complexity a little bit, in the automation realm, and, keep the high level intent to be more declarative, more descriptive, so that, those can be used to drive the run automation, which actually is, can be driven through intents. And the RAN automation solution, as you can see in the bottom, it has intent management functions. So basically, as you specify these intents at a high level, obviously, they have to be actuated and they have to be understood and they have to be realized. So for that, you leverage the knowledge database, you make a decision based on that knowledge, and then you actuate that decision, right? So these are all part of what is called an intent management function. And it goes without saying that, just as we talk about, data plane, user plane, control plane, management plane, right? We have these distinct planes. Now we have to also deal with knowledge plane. And this knowledge plane basically builds on, machine learning, because as we saw in the previous slide, we have more data now to look at in 5G networks. We can curate the data. We can use the data to train models, and those models can then be basically deployed. And there's a life cycle. Now, as you train them, you also, before you actually deploy them, you also go through this knowledge process. You apply reasoning. So you bring to bear what is called in neurosymbolic computing principles to be able to basically reason from what you have learned, before you actually actuate. And once you have actuated, you also refresh it, to keep up with the dynamic environments that you have. Now, there's a lot of work happening in this area in the TM forum. And basically, the idea is to essentially go this route. And this is sort of seen as a prerequisite, if you will, to a zero-touch operations, right? Now, if you look at how the RAN automation solution, so you introduce intent, and you introduced what is called an automated RAN management interface, which is an ARMI interface, right? Which is between the end-to-end management orchestration and the RAN automation solution. And you can see here, so there is a network intent handler, basically, which receives intents from your BSS OSS layer. And that is your management and orchestration. This is the service that I require. And then that intent network handler basically parses that intents across several other functions. On the left, it talks to the RAN, which then has the RAN intent handler. On the right, it talks to the 5G core, and so on, right? And then basically you push that down, to the intent handler support functions, which is provided through a platform like an SMO platform, for example, in ORAN, which further pushes those intent across the O1 interfaces, to reach the CUDU, for their config management, and also across A1 interface, to talk to the near real-time rig, for example. And then you also have the end-to-end tree user plane and control plane functions, that are basically used to have the RAN talk to the 5G core. And the core itself can also be provisioned, through the, through the OSS BSS system. In this case, I've just shown the UDM and the network exposure functions. The UDM is northbound, talking to, HSS systems, business support systems, BSS support systems in northbound, and NEF is basically a network exposure function talking to external network APIs, right? So you can see how we can actually use this concept to basically leverage the existing stack that we have that is being defined, but basically using this abstraction layer that we create, to introduce intents. And here I'm showing RAN working with core, transport, all of that. So, just to show you the entire thing. Now, if we were to focus on an example of how we will use intent to basically realize this intent-based RAN automation. So let's say we have two slices, one for the fixed wireless users who are receiving fixed wireless, 5G service, and then they have to coexist with mobile broadband users. So your intents that you can specify can be saying, okay, 95% of the time for the fixed wireless users, I want to make sure they have bandwidth above 25 megabits at all times. This can be as simple as that. You're specifying that intent. And for the mobile broadband services, you can say, okay, on the average, so they can all have up to 10 megabits. So it's a little bit lax in that sense compared to fixed wireless, which is more strict. And you push that intent down to the intent handler. So the intent handler, using the stack that we just saw in the previous slide, basically will push those intents down. It will receive the reports through measurements, through all the interfaces. For example, if you have an O1 interface, E2 interface, for example, the report will be generated, leveraging the data acquired from those interfaces and sent to this intent handling function, which would also then report it back to the intent owner saying, like, this is what I'm getting. I'm able to fulfill your throughput requirement for fixed wireless access and also for your MBB. Now, or I may not, depending upon where you are operating, right? If you look at the profile we have below in the night, so you have the night in the night profile, we have less mobile broadband traffic, and as the morning approaches, mobile broadband traffic goes up, and and basically peaks between afternoon and evening. Likewise, if you see the profile for the fixed wireless traffic, right? So we can between night and morning, actually, it gets more than we have configured the slice for, and it gets basically chopped when it interferes with the MBB traffic in the afternoon and evening, right? So essentially, what this is saying is that if you have a heavy situation, like in a congestion situation, we have to specify the relative priorities between intents so that they could be fulfilled in the most satisfactory way. And if the situation, for example, is persistent, for example, you're always seeing network congestion, then the message you're getting back from the system is that you have to reprovision, or have additional, sort of resources or upgrade the capacity, right? So now, if you want to relax, you also have the choice to relax the intents. Instead of saying 95% of the time, you can say, okay, 90% of the time. So you can free up, some of that capacity, to help the mobile broadband users. So basically, what we're saying here is that using intents and specifying these the intent management function, that takes this intents, you can actually realize these things. Now, there is a little bit of a challenge I wanted to bring to you. The challenge is, if you're too simplistic about how you express it, you may not be able to meet, because you may not be able to fully specify all that you need to tell the system to deliver the target KPI that you have in mind. So for example, if you don't tell the system how to use the surplus capacity, which service should get performance above intents, so you don't get that. So you have to basically tell that. And also, if you talk to CSPs, right, they will always tell you, okay, you know what, for fixed wireless throughput, I want that to be a priority, but I don't want it to be prioritized to the extent that my MBB service will be below a certain level, right? So now that's a very sophisticated prioritization schema that you have got, right? So you cannot actually express that just in a single target intent. But the good news is that if you have a utility function, if you can specify a combined utility function that takes the individual utility functions of fixed wireless access, individual utility function mobile broadband, you can actually create a two-dimensional utility function. As you can see on the x-axis is UMBB utility on the Y, and then we can try to maximize the U total, maximize the total utility, right? The U total. So using the utility functions, then we can actually tune and basically be in that green zone, most of the time, where fixed wireless customers are happy, MBB customers are happy, right? So you can see here that it's a little bit more restrictive from a fixed wireless standpoint because the, on the offset that you have on the x-axis is a little bit larger.
5 minutes.
Yeah. So basically, so the point I was saying was that you take intents, you have utility functions for those intents, but then you create a combined utility in a multi-dimensional space and then try to maximize that utility. So that way you can actually address or be in the zone that you have to be, right? Now here, what we did in the previous case was that we showed you an example where you had to do manually basically set those things, right? If the fixed wireless access was taking more or the mobile broadband was taking more and you had to adjust, you can do that adjustment because it's the time scale of that is not happening every instant, right? It's not happening every it is a little bit longer time scale. But there could be situations where you can actually leverage intent to make it leverage the same radio resource partitioning that you were doing manually in the previous case to be doing it more automated. In the case where you have multiple slices, you've created 3 partitions here, partitions 1, 2, 3. And within each partitions, you have these multiple slices. You can see for mobile broadband, we have 2 slices, A and B. For partition 2, we have a slice C, slice D, right? And what we will do is we'll basically use that operator-defined intent to set target throughputs, for each of those slices and the sessions within those slices. And those things would be measured because in an intent, when you specify an intent, it basically, before it actuates, it actually wants to see a report, whether this could be delivered or not. And then it says, okay, it can, and then it does the actuation. So the same loop that we have is also shown here. It can be automated. So we measure the throughput, and if in the respective traffic partitions, and basically if the measured throughput is below target, we will increase the share, for that partition. If it is, higher than if the measured throughput is above target, it basically decrease the share, right? So, so this way, basically, we can bring to bear this automation, right, for the radio resource partitioning. Now, the key takeaway I wanted to have for you from here was that we have the 5G network. It's complex, as we know. So many things have to be set, and automation is no brainer. It's basically it's imperative to operate it in automated fashion. Now, we also saw that there is a potential to leverage intent to drive down automation, to simplify operation control. Because, when you bring a lot of workflows, people get scared. Like, I have to, it's so complex, what do I have to learn? But now you're going other direction. You're making it simpler. You're trying to basically have the end users focus on, what they need to deliver. So focus on the what and separate, the how part from it. And the how part is basically pushed down into the implementation, which then also leverages machine learning and machine reasoning, all part of AI in significant ways in which to give you the kind of automation that we can, through that through that knowledge, decision making, and the actuation paradigm that we discussed. So we also saw the RAN automation is not sufficient to just automate RAN because RAN is connected to core and there's a transport in between. So you have to have this holistic end-to-end view. So if you're going to do intent in RAN, you would also like to do it across the board in the transport and core, and there's opportunity for doing that. Now, we quickly looked at the fixed wireless access and MBB use case. This is a POC that is actually done. So it's something real. It's not abstract or slideware. So we have some good results from that. It shows a lot of promise. We also examined the automated radio resource management. And this is a powerful approach to manage multiple slices. And, organizations such as the IEEE FNI, the AIML working group that we are part of, work in TM Forum, 3GPP work, as well as the open source projects. I think we can sort of collaborate in ways to realize, the full potential of this intent-driven network operation. So if you want to have additional information in this group and what we are doing here, we have 3 chairs. You can reach any one of us. And if you'd like to join the working group, there's a mailer. So we're looking forward to active contributions, from this forum, so we can actually work towards, the goal of realizing intent-based RAN automation or end-to-end intent-based end-to-end operation, if you will. With that, let me conclude my talk. Ashutosh, back to you.
Thank you, Deepak. Give a big hand to the speaker. So I know it's a good talk around one aspect of what is being discussed in the AI/ML working group within future networks. Yeah. There is a question here, any standardization effort happening so far regarding the example you gave, RAN or...
Yes. So there is a big standardization activity happening in the TM Forum where they're trying to specify, actually go into the ontology, all the taxonomy, all the APIs, the intent API that I mentioned, how they will look like, how those APIs, will interact, between the intent owners and the intent management functions. All that specification is a whole lot of work happening in that space. So I'll encourage you to look at their work and also join with us, basically, as part of the FNI, where we are looking in 2023 to looking at this seriously so that we can make significant contribution to this initiative for the industry.
Yeah, so just to add to that, so there is a AI/ML working group. They meet twice a month. You can, Deepak showed that. So if you are interested contributing, we are now working on the third edition. Thank you, Deepak, as the working group co-chair of IIML. Presenting.
Thank you, Ashutosh.